Hello everyone, we are Team Quark with Team ID IGC380 and this is a submission for PCCOE International Grand Challenge 2025 under the theme AI for Climate Change. Our project is titled Carbon Footprint Monitoring, Real-Time Emission Tracking and Decision Support. We address the major challenge of real-time tracking and analysis of carbon emissions across various industrial sectors with special focus on mining. As mentioned already in our PPT that we have submitted, we have covered SDGs like SDG 7, SDG 9, SDG 12, and SDG 13 that supports UN Sustainable Development Goals. And as we all know, not only in India but throughout the world, mining industry today struggles with lack of real-time emission estimation, no accurate forecasting or carbon neutrality pathways, poor data infrastructure, no actionable gap analysis, missing visual insights for reporting and compliance. So here we are with our solution overview. Through this video demonstration of how our system will work that we are under progress and developed some of the parts and some is under progress. So here we are without wasting our time. To solve this, we built a complete web platform that provides real-time emission tracking, ML-powered forecasting, net zero gap analysis, IoT plus manual plus file-based data entry, interactive dashboard that we have kept as non-technical as possible, user-friendly for the non-technical users as well, and decision support using AI insights. On the landing page, user sees our mission, building tomorrow's green solution, enabling industries to monitor, measure, and reduce their carbon footprints. Uh, Coming over the main backbone of our system, that is the dashboard, which is particularly and specifically going to monitor all of the core ideas, insights, and the ideology or innovation that we have used through various reference and research into our dashboard. So here we are. This is our dashboard overview. This is the carbon emission dashboard. At the top, we display critical KPIs, that is today's emission, which is real-time values, monthly emission, and then we have forecast accuracy, then net zero target timeline. These follow sustainability teams to instantly understand performance and risk. Then we have real-time gauge. This is our real-time emission gauge, and here we can this gauge shows current emission level versus the target range. If emission exceeds the threshold, the gauge immediately turns red, enabling quick interventions. And we have also categorized the sector-wise emissions. These are the bar charts. We break down the emission by sectors such as energy, then we have machinery, then you have fuel. We can add on different sectors also, but currently we have focused on these three major sectors, helping identifying the hotspots. Okay, then coming over the emission forecasting. This is the line chart, and here we use the ML time series forecasting to predict the next 6 months of the emission. Uh, we are working on the model accuracy currently for this, and alongside we have net zero gap analysis. We compare current emission against the net zero target. For example, here the gap is shown numerically and the color coded, and reduction milestone are automatically calculated. So this is our whole dashboard overview. Then coming over the data input. This is also a very major core part of our system. We compare current emission against the net zero target. For example, here the gap is shown numerically and color coded. Okay, that have been done. Then coming over the data input, our platform supports three models of data ingestion. That is manual data entry and IoT auto sync data entry and file upload. So we try to keep as user friendly as possible. User can manually enter the data from here, uh, where we have production output, then fuel usage, then energy consumption in kilowatt hour, and also on particular date, the user is using this particular section for data input. And from here he or she can use for the submission of the data. Then we have IoT auto sync for real-time sensor and data. Every few minutes we display last ring time, total endpoints, and active sensors. So this is all IoT sync. We can enable various hardware devices for this integration. And then we have file upload, where the user can upload CSV or Excel file for bulk data import. All formats follow IPCC and GHG protocol standards. Then covering over the technical approach that our system gonna use. So here's the short recap. Although we have all this mentioned in our PPT that we have submitted, and here's the flow, that is data input from manual entry, IoT sensors or uploaded files. Then we have emission engine activity, data, carbon dioxide equivalent using IPCC, emission factors, GHG protocol standards, domain specific mining conversion tables, etc. Then we have ML forecasting using TensorFlow, LSTM, scikit-learn regression model, time series analysis, and much more. Then we have gap analysis, compares project emission with net zero pathways. Then we have visualization, that we are gonna use React and recharts. We have used various most of the part, but some parts is remaining. So we are gonna focus on that too for optimizing the visualization. Then coming over the decision support, AI-based recommendation is there, which displays the energy efficiency, machinery upgrades, renewable integration, and fuel switching strategies. Uh, so here's the short recap of the tech stack we have used in our system. The front end, we have used React and TypeScript, Tailwind, etc. And in backend server, we have used the data processing tools and Python, Panda for data processing, TensorFlow for scikit-learn for ML, Apache Kafka for streaming, and future it can be extendable in future. We can use different message queries like RabbitMQ, etc. And we have developed so as to make it as scalable as possible. Then we have ML model, which is using scikit-learn for regression, TensorFlow for forecasting, etc. Then coming over the feasibility and viability, this is not for the users, but just for demonstration only. And we have the proven tech stack, and viability is the strong sustainability demand across industries, cost effectiveness solution reduces penalty and energy waste, competitive advantage with ML, etc. etc. Then we have impacts, environmental impacts and business benefits. I think this is the part we should focus more on, as it gonna better decision making, reduced operating cost, automated reporting, scalable for multiple mines, transparent and auditable data. Okay, at the end, we have added the research tab also, where all the research and references point have been mentioned that we have used while developing all our system. So concluding our presentation, to conclude, carbon footprint monitoring provides an end-to-end solution for carbon measurement, real-time predictive capabilities, intelligent insight for sustainability planning, a clean and accessible interface, scalable architecture for industrial adoption. We believe this platform can accelerate India's transition for sustainable mining and contribute meaningfully to global climate goals. Thank you for watching our prototype demonstration. We are Team Quark, building tomorrow's clean solution. I hope this video finds you well. Thanking you.